We're going to look today at a solution guide for the practice quiz as we prepare for our quiz coming up on the second half of the chapter. So we're just going to go through these quickly one by one and answer your questions to make sure that you are completely comfortable about the material coming up for our quiz. Our first problem is involving raising a power to a power. And so the rule for raising a power to a power, very simply, is we multiply. So we have x to the 3 times 4. So that answer is x to the 12th. Moving over, first we're going to now have a power to a power, so the x to the 6th stays at the front, but we have -1 raised to the 3rd, so that's x to the -3. Now we have a situation where we have the same base, so we're going to add these two exponents, so 6 plus -3 is x to the 3rd. Our third problem C, we have x to the 5th raised to the 0, and if you remember, anything raised to the 0 is 1, so very simply, this is just 1. Our fourth problem is in two parts. The first part is we have a power to a power, so 3 times 2, that's x to the 6th. 2 times 5, that's x to the 10th. Now we have x to the 6th times x to the 10th, so we're going to add those two together. So my answer is going to be x to the 16th. So here's 4 quick examples about power to a power. Let's continue this, and now let's talk about distributing as well. So now we're going to take this exponent of 3 and we're going to bring it to the 1 and also to the 3. When I say the 1, we could write this as 2 to the 1st x to the 3rd cubed, if this helps. So 1 times 3 is 2 to the 3rd. 3 times 3 is x to the 9th, and so my answer is going to be 8x to the 9th. Moving over, we have 3 to the -3rd, x to the -12, because we multiply the -3 times each of the exponents, remembering that there's a 3 to the 1st right here. Well, since both of those are negative, they're both going to go to the denominator, 3 to the 3rd, x to the 12th, leaving us just with a 1 in the numerator, and so my answer is going to be 1 over 27 x to the 12th. Our next one, we have 2x to the 0 raised to the 4th. Well, before we start it, x to the 0 equals 1. So the inside is just 2. So I have 2 to the 4th, which is 16. Moving over, I have x to the 4th to the 2nd. So I'm going to multiply those exponents together. And then I'm going to distribute 2 cubed and x to the 30th. 2 cubed is 8. I'm going to add the 8 plus the 30 on the x's and get x to the 38th. So that kind of is a summary over section 8.4. Let's take a look at section 8.5, where we're having powers and dividing with the same base. The basic rule that you're going to deal with is you're going to subtract the larger minus the smaller. So on this first one, it's going to stay in the bottom, and it's going to be 15 minus 3, and so that's 1 over x to the 12th. Our second, we're going to subtract once again, but this time larger minus the smaller is going to stay in the top. So we have 22 minus 11, so x to the 11th on top. For C, larger minus the smaller, the x's are going to go to the denominator, so it's going to be 5 minus -3, and the y's are going to stay on top, which is going to be 4 minus -2, so that's y to the 6th over x to the 8th. Our D is an example of scientific notation. We're going to take our calculators and we're going to divide 8.4 and we're going to divide that by 4. We're going to get 2.1. And here we're going to say -4 minus -9. So that's 2.1 times 10 to the 5th. Let's move down to our second page. Now we have fractions raised to powers. So we're going to take this exponent of 3 and we're going to multiply it and deal with it for both parts. So x to the 12th over 3 to the 3rd. Well, you probably know by now that 3 to the 3rd is 27. Our second one, we have a power of 4 going to each of our exponents. So that's x to the 8th over y to the 12th. Once again, we're multiplying our exponents. This is my favorite problem because we have a negative exponent, and remember, when you have a negative exponent, you take the reciprocal to the positive exponent, so 3 over 2x to the 5th to the positive 2. So now we have 3 squared over 2 squared x to the 10th. Let's simplify that. That's 9 over 4 x to the 10th. Our last one, we just have it raised to the negative 1, and so that's just merely the reciprocal to the positive 1. So there's 4 quick examples of fractions raised to a power. Section 6 is about geometric sequences. Geometric sequences, remember, we identify the first term being negative 2, the ratio being positive 3 as our multiplier each time. So you're going to be asked on the quiz to identify the first term, the third term, the fifth term, the 10th term, whatever the case may be. So to find the third term, we're going to take the value 3 and we're going to plug it in for n. So the n is just up here, so here it is, 3 minus 1. So that's negative 2 times 3 squared. Remember, you're squaring just the 3, so that's negative 2 times 9, and negative 18 is our answer. So when you input 3, you output negative 18. Let's try the same thing for the 10th term. So we're going to plug in the value 10 now. So negative 2 times 3 to the 10 minus 1. So that's negative 2 times 3 to the 9th. You're going to need your calculators here. So 3 raised to the 9th is 19,683. We're going to multiply that value times negative 2, and we're going to get negative 39,366 for my 10th term. To determine if something is arithmetic or geometric or neither, it's very simple. We're going to determine if it has a consistent ratio. Remember, the ratio equals the second term divided by the first term, etc. And the common difference equals the second term minus the first term is our common difference. So let's try this. 27 divided by 9 is 3. 81 divided by 27, you may need your calculators to figure that is 3. 253 divided by 81, I can't do that in my head, so I just did that on my calculator. That got me 3.12. Therefore, this is not geometric. So let's check if it's arithmetic. Arithmetic, 27 minus 9 is 18. 81 minus 27 is 54, so it's not arithmetic. So in this case, we would have to say the answer is neither. But that would be the proof and the reasoning behind it. Let's look at B. Geometric first. 16 divided by 8 is 2. 24 divided by 16 is 1.5, so therefore it is not geometric. Let's try arithmetic. 16 minus 8 is 8. 24 minus 16 is 8. 32 minus 24 is 8. Don't get sloppy here. Don't just assume that it's going to be 8. We need to check the final one. 40 minus 32 is 8. So it is arithmetic, and that is affirmed. Okay, so that's a very quick review of our problems from the practice quiz. I hope this has been helpful as we prepare for our quiz this coming Friday.